Welcome to Spring LIB.
So in this question, we have a longitudinal wave that is 524 Hz. And it has a speed in air of 345 meters per second. We ask A, what is the wavelength? B, how much time is required for the phase to change 90 degree? T for phase to change 90 degree. So we see that the phase for a whole wavelength is 100. Is 2 pi, it's 360 degrees. So for something to change 90 degree, it's asking for what is the period divided by 4. Part C is at a particular instant, what is the phase difference between 2 points that's 4.4 centimeter apart. Okay, so let's look at them one by one. Part A we just use lambda equals V over F. This is an equation we have in the very first section of this book, of this chapter, and V 345 meter per second over 524 hertz equals 0.658 meter. Part B, so as I mentioned, for a whole period, which is 360 degree, it corresponds to a time of T, a big T, a whole period. So for 90 degree, it corresponds to a time of 1/4 of a period, because delta T equals delta 5 over 360 degree times big T, which is 90 degree over 360 degree over T, which is 1/4 of a period. And we can find the period because period is over frequency, and we already know what frequency is. So this equals 1/4 times 524 hertz, which is 7 times 10 to the -4 second. Last question asks how much phase change is introduced at two points that is 4.4 centimeter apart. So we have the same relationship here. The phase difference divided by a whole phase. Previously we said it's equal to delta T over T. It's also equal to delta X over the whole wavelength. So now we have phi equals 360 degree with this ratio. And delta X, 4.4 centimeter, 0.04 meter. Lambda, as we calculated previously, is 0.658 meter. So this tells us how much 4.4 centimeter is. So like how much portion is 4.4 centimeter in terms of the whole wave. And this portion is how much phase we get outside out of 360 degree. This tells us it's 24.1 degree.